All right, so what we want to do now is we've looked at some scatter plots. Now remember, what did I tell you about a scatter plot? Do we join the dots in a scatter plot? No, it's exactly that. It's just a bunch of points. Now we can fit a line by just sort of drawing a line there. That's all well and good. But we can actually fit a line by eye, and we can actually then work out if I draw a triangle, for example. What was, now you guys would have done year 10 maths. What did you call this thing, like this height here? What would you call that in terms of? The rise, isn't it? It's the rise. And what's this? It's the run. Now, in order to find an equation of a line, what do you need? You need, what does this thing, isn't this the equation of a line? Is that right? Now, if that's the equation of a line, what does rise over run give you? It gives you the gradient. Now, we need two things though, don't we? We need rise over run, and that's going to give me the gradient. But we need to know two things. We need to also know C. So we need a point on that line as well. So, if we have a look over here, fitting by eye, and I just zoom in a little bit, this is done by placing a ruler on the scatter plot so that it runs roughly through the middle of the data. Now, roughly through the middle, it's not going to be exact. You're not going to get an exact value. If I was ever asking you to fit a line by eye, I couldn't say, well, your line had to be exactly this equation, because you could do a slightly different line with a slightly different gradient. It's an estimation. It's not the best method, but we might certainly ask you in an assessment that you'll have to fit one by eye. Now, once the line's drawn, this is y equals a plus bx. Well, in this case, this is the gradient. The gradient is the coefficient. The coefficient of x. What does the coefficient mean? The letter, the pronumeral in front is the coefficient. So the gradient, though, now you might also see as this, and it looks ugly, doesn't it? y2 minus y1. Well, let's consider two coordinates. If I have a coordinate here and a coordinate here, the one on the left is always the 1, okay? So x1, we call that. That has a coordinate of x1. And what's this other coordinate? y1. Now, of course, this coordinate, because it's on the right, is x2, y2. Now, if I was to find the gradient of that, all it is just asking, so I want to find, so this here, this distance here is the rise. This distance here, that is the rise. And of course, this distance here is the run. That's all this formula is. So if you want to just draw a triangle and basically, if this coordinate here is 1, 1, 3, and this coordinate over here is 3, 9, well, what's the gradient? Do you have to do it this formula here? I don't think you really do as such. Just think about how much does it rise? Well, it goes from 3 to 9. So the rise is equal to 3 to 9. It goes up 6, doesn't it? So it goes up 6. And it goes from 1 to 3. So the run is, or this distance here, is 2. So rise over run is equal to 3. So that means that our equation would actually have y equals 3x plus some other constant. It could be c, whatever you want to call it. I'm going to call it c. So how do we find c? Well, if I use my ruler, couldn't I actually, somewhere that would actually take me to the y-intercept? Because you might recall from last year that this here is the y-intercept. Okay, and your y-intercept is going to be very rough. It's not going to be exact when you're doing it by hand. Alright, so if we have a look at something like this, the scatter plot below shows the height of a child over a 10-year period. Draw and find the equation of the line of best fit. Now, let's have a look. First of all, I'm going to get my ruler. This is probably not the greatest example, but let's just say I want just as many points above and below the line. So I'm going to sort of, let's just say I'm going to go, and I would have a ruler, of course. I'm going to sort of draw a line which sort of looks like this. We've got, all right, let's just say that you've got sort of 1 point on that side of the line. You've got quite a few on the other side. Probably could go just a fraction more, like so. Now, if I trace that back to the y, let's just say that the y-intercept's there. Well, what is that? Well, you need to then make an estimate of what that is. Now, let's just say that we're starting off at, well, this is 90. That's so this is going up in fives. Let's just say that that's about 85 centimetres. Let's just say that that's going to be 80 centimetres for the time being. So let's just say that that's, I don't know, 82, yeah? So what it means is that my value there is in y equals mx plus c, my c value by ruling it out, and this isn't the best example, but my c value is going to be approximately 82, and that's a guess, that's just the y-intercept. This value here though, what do I have to do? I have to pick 2 points on the line. So what I'm going to do is I'm just going to rub this out, and I'm going to pick, now it has to be 2 points on the line or of your line of best fit. But for the time being, I'm going to sort of say that my line was pretty much went through, let's just say that my line went through, probably went through that. Let's just say my line went through that point and that point, just for argument's sake. So of that line that you fit, you then need to pick out and work out what? Well, we need to work out this gradient here. And this gradient here we can work out using good old rise over run. Now if I was to get this, and I'm going to sort of do some estimation here. What's this coordinate here at age 4? What should we say? That's maybe 100 and, should we just have a bit of a stab at about 102? Yeah? So I've got the coordinate, that coordinate there is 4, 102. Now I could call that x1, y1 if you like, that's fine. And I could call this coordinate over here now, let's have a look, that's age 9. At age 9 we've got, I don't know, is it pretty close to 135? Yeah, let's just say for argument's sake it's 134. So you might be a little bit off, that's fine. x2, y2. And that's going to be 9 and let's just say 134. Alright, so now what do? Well, first of all, we've got our height. We've got to find the relationship between our height, which is our, as we discussed yesterday, isn't it that our response variable? And our explanatory variable is age, yeah? How else do we know that? Age is what? The independent variable, how you might remember this in science. Independent variable you now need to consider is the explanatory variable. And this here, which was dependent variable, is now called the response variable, isn't it? So height is responding to age as such. Now, it would make sense though, it's going to be a pretty linear relationship. As you grow older, you get taller. Let's have a look then at, we've worked out the age. Now, this constant is 82. Now, it doesn't matter how you add 82 with the coefficient mx, but of course, you're used to seeing the constant at the end. So, let's work out what this is. Now, it's times the age. Now, we could call age x, we could call age a, it doesn't matter. It's just a variable, just a pronumeral. But we want to know what the coefficient of that is. So what we need to do is we could work out rise over run. Well, we could say y2 minus y1, which is 134 minus 102, over the run, which is 9 minus 4. You're not always going to get a nice round number, especially when you're doing things in your calculator. If you're going to do some rounding, you might want to round to 1 or 2 decimal places. But what's that going to give me? I'm not going to use my calculator for that. That's 32 over 9 minus 4, which is 5. Now I'm going to do that in my head. That's going to be 2/5 is 0.4. So that's going to be about 6.4. So 6.4 means, there you go, that's 6.4. Let's do a little bit of a test. Let's do a little bit of a test now, just to see how accurate we are. Let's just say, if at age 10, because this is an example over here, at age 10, what did we see here? A height of what? About, what, 140, do you think? About there? Let's test it out. At age 10, if I plug in age 10 into there, 10 times 6.4 is equal to 64, plus 82. 82 plus 64 is equal to 146 centimetres. Now, that's not too far off, is it? Now, it is ultimately a little bit off. This is just a line of best fit, okay? And your lines are going to change. But what if I was to ask you this, and be careful, the equation is 6.4 times the age. Now, the age might be called A, it could be called X, whatever you decide to call it. Just make sure you declare your variable, plus 82. And that's our relationship that we've fitted by hand, by using a ruler to find the y-intercept and to find the rise over run, which of course gives me this value here, 6.4. All right. Now, for the time being, can I just emphasise that 4C, you do not have to do 4C. 4C is actually another method that we're not doing. So what we're doing now is fitting a line by, and that's using your CAS and stuff like that. We're going to be doing the questions from 4D. Okay. Now, just quickly though, if we ever make predictions, I might just actually, you know what, I might stop that video there. I might stop that video there because it's already gone for 12 minutes. I don't want them to go for too long. And in the next one, we're going to go through making predictions.